Right, hello everyone, and welcome to today's Facebook Live teaching, the first session of 2019. Right, I believe most of you are here would be newcomers, so let me just give you a brief background about what this is all about. So we have been doing Facebook Live teaching for about 1.5 years now. We started back somewhere around 2016, middle of 2016. And we've been progressing and improving on our way of delivery of this online teaching. So this Facebook Live teaching is to help parents, to share with parents what are the various heuristics that's being used at P6 or in general the primary level, because what we went through in school is is actually very different from what the students are facing nowadays. Okay? Hello, Barry, TK, Raven, Belinda, Yo-Yo Zizai, Leslie, Shiwen. Okay, so this will be conducted every Wednesday at 8 p.m. If there is a public holiday, then there will not be any broadcast. Okay, so since that's the start of the year, it's been a while since I did FB Live. Let me get warmed up as well. So let me introduce you a bit about myself. So I started working here at Maths Heuristics since 2011, so it's been about 8 years now. And I graduated from NTU with a degree in mathematics and economics. So maths has always been one of my strongest and favorite subjects. And to be able to teach it to kids and to be able to see that eureka moment when they get the concept, that is one of the most rewarding parts that I live for in this career. Okay? So let me tell you a bit about my company. It's not really mine, I'm working in it. But take it from me, I treat it as a very dear company. So it's about the Mastering Heuristics series. Maths Heuristics has published 5 books in total to date. So this will be on the border approach, the unit transfer method approach, speed and rate, and spatial visualization. And these books will cover in detail what the students will be facing at the primary level. So for today's topic, you notice that we will be discussing about UTM and model. So these are the 2 books over here, which are quite different in approaches, in the way that it's being presented, but the fundamental mathematical idea is very sound. Okay? So now let's talk about the search for the Holy Grail. Okay, should we learn the model or the unit transfer method or both? This part, I believe this question pops up very often in parents' minds, because I had a client who just came in earlier this afternoon who was also asking me this as well. Okay, there are some generalizations on when models should be used. It's a general guideline, but not absolute. Okay, I will answer all this in a while. Which method is faster or easier? So for this particular point, you have to be asking yourself one thing. Is it for the parents to understand, or is it for the students to understand? At the end of the day, the most important thing is the child must be able to understand and do and be able to get it right. Not so much for us. For me, even if I want to take my PSLE again, I don't think I can. I don't think they will allow. Which level is this for? Now, units method start as early as P4, but by P5 everyone will be exposed to it. So the issue here is that at the P4 level, we need to start making them, making exposure of the units method to them. And why is that important? Because in Singapore Maths, we always talk about this CPA approach. And what is this CPA approach? It stands for concrete, pictorial, and abstract approach. Okay, so at P4, most of them are doing these word problem sums with models. And when you go to P5, you suddenly notice that they are not really able to cope with everything that they were doing before, because this transition was not formed properly. Okay, so why is there a need to use units method at P5 and P6? The reason is because that when you start to go to more difficult questions, more challenging problems, you will notice that the numbers are not so friendly anymore. And secondly, your numbers can be rather large. So that is why we are using abstract reasoning, mostly in ratio or fractions. And to just dump them the abstract approach straight away, they are not able to see the connection of what they have already learned at the pictorial stage. And this part would make a lot of them struggle, unless the child is already very strong. But not every child is like that. So we should expose them from pictorial and do the transition to abstract reasoning through this way. Okay? Then next is the unit transfer method taught in school, and will my child get marks deducted? I'll answer all this later. And the one question that is on your mind right now is whether you should use model drawing or unit transfer method to solve these problems. Okay, so today I will show you some carefully illustrated examples of when, and describe when model is better, when UTM is better. General guidelines. Okay? Okay. So let me see. Yeah. Alright, let's get into the lesson proper. So first Facebook Live session of the year. Let's start out with something simple that all the P4s can do, because this is primarily dealing with fractions. Okay. So you see that 1/5 of the children at the playground were girls and the rest were boys. When 8 girls left the playground, the fraction of girls decreased to 1/7 of the total number of children at the playground. How many children were there at the playground at first? Okay. Let's identify what we have and define what we have first. Now this was before anything happened. There was a change over here. It's usually characterized by an action. Then the fraction of the girls decreased to 1/7 of the total number of children at the playground. Hi Eunice. Hi Lenny, Desmond. Okay, so in order to deal with the model, this is what I would recommend. If you're at P4, this problem will be considered challenging. But if you're at P5 or P6, this will be intermediate or basic. Okay? So what I recommend for the model is you draw a before and an after model. So there is boys over here and there's girls over here. Later on, there will be boys and there will be girls. Okay, if 1/5 of all the children at the playground were girls and the rest were boys. It means that for the children, you can split them up into 5 equal portions. One of them belongs to the girls, and 4 of them must belong to the boys. Okay? So now, the change here is that 8 girls left the playground. If we are to draw out the after model over here, it must be that the case that the girls bar is shorter than the one on top. And if we are to look at it in this perspective, there would be an 8 over here inside the blue box. Okay? Now the fraction of the girls decreased to 1/7 of the total number of people at the playground. Here you have to be able to see its implication. If one red block goes to the girls out of a total of 7, that means that your boys will have 6 red blocks. Okay, and that is not the only information that you have. There is one more part on top of that. Because your boys did not change at all, there is no statement about the boys' numbers being altered. We have to draw these 6 blocks to be of the same length as the 4 blue blocks on top. So we'll draw 6 of these red blocks like so. Okay? And once we have done this, we need to see that in every blue block, this can be cut into 1 red block and 8. Okay, 1 red block and 8. So we extend this to all of them. We make every blue block become 1 red block and 8. Okay? Hi Alicia. So once we have done this already, the next thing that we can do is to rearrange them. If you can't really see it, we can rearrange them. Let me just copy this into a paint file. Okay, how to rearrange them? We want to move up all these 8s and compress all the units together. So if we are to do this, what will we end up with? We will have 4 of the red blocks on top and 4 copies of 8, which gives us 32. This is your before boys and this is your after boys. Your after boys can be split into 6 of these blocks. And once you are able to do this manipulation, you can form the connection and say that these 2 units must be 32. Okay? So let me just put this back into the PDF for clarity. Because I don't want to mess up my model on the right, on the left. So once I have this already, I can say that 2 of those units is 32. 1 unit must then be 32 divided by 2 to give us 16. over here, this 1 unit we are talking about is one of these blocks over here. Okay, so to find out the total number of children in the playground at first, we see that there's 1, 2, 3, 4, 5, 5 blocks of 16 and 5 copies of 8. So this will give us 80 plus 40, a total of 120. Therefore, the answer here is 120. Okay, can you all see it clearly? Okay, Josh, I'll go through it in another way very shortly. Hi, Barry and Jonas. Hi, Shirley and Sherlyn. Okay, so now I will go through this in the unit transfer method way of doing. Similarly, the question is the same. So let's just input in the situation first. Okay, but to do it by the unit transfer method, you want to list out between girls and boys the before, change, and after. We go according to how the situation is. Okay? If there is a before, change, and after, we just list out before, change, and after. 1/5 of the children at the playground were girls, the rest were boys. So we can say that over here, I will use numbers instead to represent the number of blocks that I have. Then after that, 8 girls left the playground. So there is a change of -8 over here. The fraction of the girls decreased to 1/7 of the total number. So similarly, there will be 1 red block for girls out of a total of 7. Which means that for the boys, you must have 6. Okay. So once we have done this already, hang on, I think there's something wrong with my. Once we have done this already, we can now say that we want to look at the change row, because in a before and after problem, the most important aspect is the change. Without the change, there is no before or after to talk about. If you are 60 kg last year and you are still 60 kg this year, there was no change to your mass. Agree? So there is no action, there won't be any change. Now in this case, we can say that these 4 and this 6, 4 big blocks, 4 big blue blocks and 6 small red blocks have an equal length. So what we want to do here is to make them the same. Now what do I mean by make them the same? We want to subdivide them into their lowest common multiple. Okay? And the lowest common multiple is the smallest number that can be divided by both 4 and 6 without any remainder. Okay, so between 4 and 6, the LCM is 12. In order to get there, I will need to cut this into 3 blocks each, and I'll need to cut these into 2 blocks each. When I have done this, I will have 3 units here, and I'll have 2 units here. So now, over here, everything has been cut into the same subunit. And everything is now comparable. Okay, let me just show you what's going on in the model parallel. You do not need to draw the model, but this is for your appreciation. Okay? Four blue blocks is equal to 6 red blocks. So we have to cut them all up into the same subunit. And this is what's happening. Hang on. Okay? So once we have done this already, we can look back at the table. Then we ask ourselves, what does this all mean? From 3 subunits down to 2 subunits here, what happened? There was a change of 1 unit. And where did that come from? It came from these 8 girls who left the playground. So we can say over here that 3 units minus 2 units is going to be equal to 1 unit, which is 8. And then, if that is the case, we can then easily find out how many children there were at the playground at first. So over here, we need to find the most updated subunit, because every one of these small blocks is now 8. So we sum up this together. That will give us 3 units and 12 units, a total of 15 units. And to find 15 units, this will simply be 15 copies of 8. And this will also give you 120. Alright. Hang on, let me log into this again. I think my video is lagging on my handphone. Okay, so in FB Live, the lag is quite, there is quite a big lag. So in order for me to gauge your understanding here, is it possible that you spam the like button? Okay, there seems to be some technical difficulty on my side for my mobile. Let me try the tablet. This is what happens when you haven't been using Facebook Live and you use a much better platform for the last 2 months. Okay. Okay, thank you for the spamming the likes. Okay, if you do not understand the question, which part do you not understand? You have to be very clear about this, because what I always tell our students is that you need to pinpoint exactly where the choke point is, because if you do not know what you do not know, then both of us is going to have an issue. Okay? Okay, thank you for all the likes. So let me go on to example 2. When you look at this problem here, okay, let me just read it out first. And then we decide whether to use model drawing or UTM. Okay, I'll answer your question later. Hi, Clarice. Now, Tom had an album of Singapore and Malaysian stamps. When he gave away 50 Singapore stamps, there were twice as many Singapore stamps as Malaysian stamps. Now, after his brother gave him another 63 Malaysian stamps, he had thrice as many Singapore stamps as Malaysian stamps. How many more Singapore stamps than Malaysian stamps were there in Tom's album first? Okay, let's just identify what we have. This is your before. There is a change over here. And then there is an after result. Then after that change, there is another change that continues on. It's not your case 1, case 2. It continues on from the previous event. And now you have another after result. So let's interpret the problem first. Would you use model or unit transfer method, and why? Okay, let's hear from you first. Okay, Mary, why UT? Okay. Okay, for those who say UTM, why UTM? Those who say model, why model? You see, when you have two changes, you're going to have a before, one after, and another after. So what this means is that you need to draw out 3 diagrams over here. On the model side, this can still be done, but I won't go through it here. You can do it as an exercise. Yeah, Lenny, very good. The UTM will make the representation a lot clearer. Okay? Thank you for the answer. So now we see that I will use unit transfer method for this, and you will see that there's a Singapore and Malaysian stamps, and we go according to what the situation is. Alright? Okay? So over here, let's just list out what we know. He gave away 50 Singapore stamps. There were now twice as many Singapore stamps as Malaysian stamps. So let's just allocate that in. His brother gave him another 63 Malaysian stamps. So he got 63 Malaysian stamps. And now he has thrice as many Singapore stamps as Malaysian stamps. So change this to 3 out of 1. 3 goes to Singapore, 1 goes to Malaysian stamps. Okay, so up to here, we haven't really done anything heavy yet. We were just interpreting the problem. So once we have that, this is a rather special case, because if you are to isolate out this box over here, you will see that inside this change row, there is no change for the Singapore stamps. Okay? If you are doing it by model, you have to read the question carefully and infer that there is no change for the Singapore stamps. Okay, that's very important. So once we have that, we can say that these two big blocks here is equal to these three smaller blocks here. So we want to make them the same. We cut them into the lowest common multiple, which is 6. So to get there, every block over here needs to be cut into 3. Every block over here needs to be cut into 2. So we do that in order to maintain equivalence. Right? Like Karina and Vera. So once we have this already, following the same idea from earlier, from these 3 units over here down to these 2 units over here, we can say that there was a change of 1 unit, and that 1 unit came from the 63 Malaysian stamps that the brother gave him. Okay? So now, what is it that I need to find? After I get my 1 unit, solving the problem becomes much easier, because very often, the problem hinges around this 1 unit idea. There are some exceptional cases where they ask you to find the ratio of 2 items. And those are rather rare, I think. So you see that if you have 63 here, you want to work backwards and find out how many stamps of each type he has at first. So for the Malaysian stamps, this is rather easy. Because there is no change for him, we can say that 3 units here would just be 3 times 63. This would give us 189. And for this, you have to be careful. You find out the number of Singapore stamps at this point first. That will be 6 units. So 6 units will be 6 copies of 63. This will be 378. And then, one very big common mistake that students make is that when they want to find out what's happening before, they go and take, don't write this down, don't write this down. They go and take 378 and minus 50 again. Do you find anything wrong with this? Okay, Belinda and Barry, very good. 63 is 1 unit. Remember, here you are working backwards to trace back to the original value. Something minus away 50 gives you 378. So in order to find out that value, that has to be 378 plus 50 to give you 428. So once we have this, we can find out the difference already. It will just be 428 minus 189. So that will give you 239 over here. Okay? Okay, so if you got this idea, please spam the like button so that I will know. Stefan is asking, is there another method? Yes, you can do it by model as well. Okay, very good. Okay, Belinda is asking why plus, not minus. See, this is going forward. Something minus 50 will give you 378 over here. So here you are taking back, you just imagine after you gave away 50, you are left with 378. So here, when you work backwards, you are taking back the 50. When you do that, you should be adding it back. Okay? Angeline Low. I think I find your name very familiar. Long time no see, I guess. Alright, thank you for spamming. So at least I know what you're gonna do. At least I know that you all understand so far. Okay, so let's go on to number 3. So by now, you would be thinking that unit transfer method is a superior method to model. Okay, let me first and foremost say that there is no superior method. Only the method that works for your child. Whichever he can use to score consistently, that would be the most suitable method for him. Okay? And that is my stand. To illustrate to you why I say that, let me start this with the unit transfer method first. Okay? So over here, Ali had $50 more than Benny. There is a before over here. There is this change over here. Benny given Ali $28. Ali had 3 times as much money as Benny. So how much money did Ali have at first? Okay, so over here, to do it by unit transfer method, you will see that, okay, we want to draw out the table, compare between A and B. Okay, when we see that Ali had $50 more than Benny, we tend to write this out like this. There will be 1 unit here and 50, another 1 unit over here. Benny gave Ali $28. And at the end, Ali had 3 times as much money as Benny. So now, you would have blocks of different lengths. We have to call these parts instead. And once we have written everything out, we can see that there's 2 statements that can be formed. 1 unit plus 50 plus 28 will give us 1 unit plus 78, which is 3 parts over here. Then the next one would be 1 unit minus 28 is equal to 1 part. So over here we end up with a bit of a problem. The next question here is, what do you need to do to find out the value of 1 unit or 1 part? This is a simultaneous equation. If you are to draw this out in model, we are using pictures to represent that simultaneous equation as well. Okay? So, in order to deal with this, some of the parents who are algebraically trained will teach your children to minus this whole thing. Okay? Nothing wrong with that, but you need to know how to deal with this. Because what most children will do is they will take 78 over here and simply minus off this 28 over here. Okay, don't do that because this minus sign affects all the terms inside this bracket. So how do we avoid this? How do we avoid using algebra over here, especially at P5 and P4? So over here, we will need to use models to draw out these 2 diagrams and show it. So in this sense, the model approach also complements the unit transfer method over here. Okay, we can draw out these 2 models like this. You have 1 unit minus 28 equals to 1p. Okay, as a general rule of thumb, you want to start off your model with the negative statements first. This will make it easier to fit in the positive model later on. So your entire bar here is 1 unit, and you are taking away 28. This leaves you with one part over here. Next up, you have 1 unit over here and 78. This gives you 3 parts in total. So you can see that if we are to compare between parts with parts, numbers with numbers, okay, we extend this one down, we can see that over here, this will have to be 2 parts. Correct? No, you don't minus 50. No, you don't minus the 28. Don't minus the 28. You look at this gap over here. The model is there to guide you on what steps you need to take to solve the problem. Not so much, it's not drawn for fun, okay? You have to look at it. And over here, we are seeing that the gap is getting bigger. Hence, we should be adding to find out this length over here. So we have 28 plus 78 to give us 106, which is those 2 parts there, right? How did we get 2 parts? We simply took 3 parts minus 1 part. And this gave us 2 parts, so 1 part will be 106 divided by 2 to give us 53. And once we have that, we can easily now find how much money did Ali have at first. Now take note that this is in terms of parts. So what you want to do is to find out his 3 parts at the end first. 3 parts will be 3 times 53, give us 159. And from here, we simply work backwards. To obtain what he had at first. So the answer here will be $131. Okay? Okay, so if you got it, please spam the like button. Yeah, 1p is equal to 106 divided by 2, which will give you 53. So here in this case, you can see that the model actually complements the unit transfer method. Of course, for students who are visually inclined, they can start off straight away by drawing the model. They can also get the answer. But generally speaking, for this question that involves more than or less than, even if you are to compare the total over here, you see that there is nothing that you can make the same. There is no repeated identity where you can cut them into subunits, and hence using UTM to solve this type of problem will be harder. Okay, so in this sense, in this regard, the model complements the unit transfer method, and hence it is important to expose your child to both methods. Okay, Stefan, Stefan is asking if I can repeat one more time. I'm afraid not. I'm running out of time soon, so you can view the recording later on after Facebook is done processing the video. Based on the drawing, and you also take 1p 53 plus 28 plus 50. Yeah, it can be done also. Okay, so that is the end of my presentation. So now I will answer all your questions. Should my child learn the model or units method or both? I think I've given a very solid demonstration in example 3 why you should learn both. And at the same time, MOE's stand is that there are several heuristics and all the children should be exposed to all these heuristics first. And then you let the child decide for themselves which is the best method for them. Okay, there are a lot of faster or shorter methods around. I do acknowledge that. I'm aware of that. But if the child doesn't understand how these shortcuts are derived, and they are not able to tweak it and apply it to other questions, then that would be defeating the purpose, because you are learning a specific method for a specific problem. Then you better pray hard that that comes out in PSLE. Because 2018 PSLE, there were 2 very interesting questions. I want to talk more about them later on in this year. Okay, 2 very interesting questions. So which level should my child start to use unit transfer method or units method? It depends on how well versed he is in the pictorial first. Of course, there are some children who are very weak in pictorial, but abstract reasoning, they are very good. So you can start to explore this with them first. Okay, next, is the unit transfer method taught in school? My answer would be yes, and I tell you why. Unit transfer method is fundamentally based on ratio reasoning. The school's way of doing also uses ratio. At the same time, for unit transfer method, what we do is we tabulate all the information and organize it first, so that it's easier to retrieve the information and process it from there. So it's very similar in logic to what the school is doing. The presentation may be different. Okay? Then after that, will my child get marks deducted if the teacher does not understand unit transfer method? Okay, this pops up a lot, so I'll do my best to answer this. Okay, for certain schools, they have their own practice, they have their own way of doing things. But at the PSLE level, it is stated that all workings that are clear, concise, and logical, marks will be awarded for these workings. Okay? So here, let me introduce you to something. We are working with Tenopy to provide live online maths classes from primary 3 to primary 6. So what benefits does this have? There will be real-time interaction, just like this now, except that Facebook Live always has about a 10 to 15 seconds lag. And you can clarify your concepts on the spot, just like in this live chat, which is about 15 seconds delayed. Live interaction with tutors and friends. So here there are questions that if you have questions you can ask me. Okay, over there with Tenopy's platform, it will be very close to real time. The lag, I assure you, is less than 2 seconds. Okay, the moment you type out or you say something, I can hear it, I can see it already. So how does this live interaction work? You will see that over here in Facebook Live. The most you can do is spam the like button and type in the chat box. But with Tenopy's platform, what we can do is I will be able to see your child and your child will be able to speak to me. Okay, so there is another concern on this. Would the class become too rowdy in that case? Don't worry, I got it all under control. I will only let the children come up to speak when they have a question to ask or something that they want to discuss in class. Okay, then for the rest of the time, the chat box will be shut off and only I can view it. The reason for this is to limit the distractions and let the child focus on the lesson at hand. Okay, for time saving, I believe for most of you, if your tuition class starts at 1 p.m., you won't exit the house at 12:50 p.m., correct? I have parents who stay at Sengkang who come all the way to Novena for my class. I'm very, very touched by that. And I often remind myself to do my best for these parents who make that extra effort. So, from Sengkang to Novena, I think it's no joke. If you're taking a bus from there to here, if you're coming by public transport, it is easily more than 1 hour. So, a 1 hour, 30-minute class can end up to take you about 4 hours in total. But with Tenop's platform, you can simply log in from your house 5 minutes before the lesson starts, print out the worksheets, and we can start the lesson straight away. Then the next one is, because this is an online platform, your child may not be too used to this at the beginning, and you'll be wondering, what if there are certain parts that I go too fast? What if it's not able to catch? There will be recordings available after each lesson, okay, that they can review back the parts that they do not understand, or if I was speaking too fast, they can go back and rewind and watch it again. I also do this for my offline classes, okay, by the way. So over here, this is what I will this is what we can offer you. Use this URL to go and access this trial class. At Maths Heuristics, we want to give it free, 4 lessons, for your child to know himself, for us to know them, and for them to get used to this platform, to see if they are suitable for online learning. So we are very confident that this is a very good product and service, and we are willing to give it for free. That's how confident we are, because we are one of the pioneers, if not the pioneer, of online learning in Singapore. So there is a $5 processing fee for the admin at Tenop, but it should not, but the value that you get back will be much, much more that amount. Okay? So this offer will end tomorrow night.